Hello everyone, so in this video we have to draw the structure for the following molecule that shows the approximate bond angle around the nitrogen atom, so the N atom, and describe the polarity of the molecule. So here we're given this huge molecule here and we have to go ahead and draw this out. So dipole moments occur in bonds as a result of differences in the electronegativities of the bonded atoms. The difference in electronegativity results in the separation of charge, creating what we call a dipole moment. So this partial charge distribution results in the polarity of molecules. So highly electronegative atoms such as nitrogen, oxygen, and fluorine develop a partial negative charge, while atoms like carbon and hydrogen, which are less electronegative, develop a partial positive charge. And we can usually see its symbol being delta positive, so delta plus or delta minus. So molecules like groups for NH or OH are generally more polar than molecules that are simple hydrocarbons, so just hydrogen and carbons. So the given molecule is polar due to the presence of both oxygen and nitrogen. The nitrogen atom is given in the molecule as part of an amide functional group. The lone pair of electrons on nitrogen are involved in a resonance with a carbonyl group. So for this resonance to occur, both the nitrogen, hydrogen, and the carbon and oxygen must lie in the same plane. So the hybridization of nitrogen in amides is sp2, and a sp2 hybridized atom has a bond angle of 120. So with all this information in mind, let's go ahead and draw the structure. So we can see here that we have this compact sort of written out recipe for the molecule. So starting off with my CH3 at the terminal end. So we have this carbon with 3 hydrogen atoms, and that's connected to another carbon with just 2 hydrogens. So we have one here and one here. Then followed with another carbon. This carbon will have its double bound oxygen as its functional group here. Then we can see that connecting to a nitrogen group with 1 proton there, connected to another carbon, and that's a methyl group, so we see we have 3 hydrogen groups at the terminal end. And of course on my nitrogen we do have 1 lone pair to fulfill its octet, and we see on the carbonyl oxygen that we do have 2 lone pairs present there. So for the resonance to occur, like we said, what's going to happen is that we'll have our pi bond from our carbonyl group coming up to make a lone pair on the carbonyl oxygen. And then the lone pairs on our nitrogen is going to go ahead and form a double bond between the bond that's already present between the carbon and nitrogen group there. So we're going to simply follow our arrow pushing. We can see on the left side of our molecule, everything does remain as is. So we have this terminal carbon here with 3 hydrogens, followed by another carbon with just 2 hydrogens since it's a central carbon this time. Then we have another carbon. This is the carbonyl carbon here. So what's going to happen is that the bond between the carbon and oxygen will only be a single bond now. This carbonyl carbon, or this carbonyl oxygen, will have 3 lone pairs, giving it a -1 formal charge. The bonds between the carbon and nitrogen is now a double bond, so it has gained a pi bond. And since we have used the lone pairs on the nitrogen, it will now only have the 3 bonds, we could say, and no lone pairs, or just 4 bonds including this pi bond, and it does gain a +1 formal charge. And the terminal carbon here with the 3 hydrogens remain untouched. So we still see that we have a neutral molecule over here in this resonance structure because we have this +1 and -1 charge, which they do cancel out. So we can see that this molecule is polar given that we have our oxygen and our nitrogens, and the bond angle that we see present here is going to be between right over here, and we see that this angle is going to be at 120. So we focus on in the nitrogen here, we see that we have sort of these 3 bonds, and that's a 120 angle. So same thing for my other resonance part here, we see that this is going to be 120. So that's going to be my final answer for this problem.